Okay, so guys, those who are joining here as a to attend the demo session. So let me just brief you. Today I would be showing you something from the firewall mastery point of view. In the last class, I had covered up for CCIE security, and the demo video. The recording is already available in the YouTube channel of ours, so you can go through it, or I'll give you after over on the chat window in some time. So let's talk about the Firewall Mastery combo course. So here in Firewall Mastery course, it's a combination of five top firewall technologies. Okay, so starting with ASA FTD, Palo Alto, Big IP F5 LTM, Checkpoint, and FortiGate. So someone who is getting out of their routing switching domains to a firewall or a security domain. So, so for you guys, this is actually a good opportunity to upgrade because you would be learning the top five technology that is used in the security industry. And this is the lab that it looks like for, let's say, Checkpoint. We have this lab for F5. This is the lab for ASFTD. This would be the lab. Okay, for Cisco ASA, this is the lab. And the curriculums are put up. You can just go through this, and I'll give you the link. So you can go through the syllabus copy. It's basically from beginner to an advanced level. So we will start with a very basic level initially, and then we will keep enhancing the class after class. So what I'll do is I'll take a quick small session today. Might be I'll show you Palo Alto and walk through something on the Palo Alto dashboard. So as you see, this is one of the lab that we have reserved for the Palo Alto learning. So we will see Palo Alto interface configuration, deployment mode, security policy, VPNs, SSL decryptions, certificate management. So a lot of things with respective to Palo Alto. So now let's assume you are here or you do not have any knowledge about Palo Alto. This is your first class. So let me just walk around over on the backend CLI commands. So this is the console of Palo Alto. You can trigger some commands like show interface management. It will give you an IP address. Okay. And take this IP address and put it down on the address bar. You will get the graphical web page of your Palo Alto. So this is how you take the access of the Palo Alto. Okay. What is the command? Show interface management. You put down on your browser and you have the access to this. So before I walk through the dashboard, let me just walk through on bit of the CLI commands. Again, Palo Alto is not meant or to be controlled or handled by CLI. Those are very legacy device which we do CLI based. But nowadays we can do a lot of things from the graphical interface. CLI is used only for either initial configs or for troubleshooting purpose, capturing of a packet or vice versa process. So what are different commands here? Let's say show system info. This will give the complete picture of your Palo Alto. It's a VM based. This is a management IP. This is a subnet mask, right? This is the uptime. You can see the uptime with you. If you go and try to see the session info, if in case there is any sessions built, if you want to see something for disk space, right? So you can go with show system disk space files. So you can get to know what is the storage going on. So it differs vendor to vendor. The commands will differ. If you are good with Cisco, might be then it should be. easy for you to remember the commands of the other vendors. But again, there is no correlation. Say, for example, if I do show IP int brief, the command in Palo Alto would be a bit different, something like this. If I want to see the CPU process, I usually go show CPU, show process CPU sorted, right? The same command, equivalent command, I can say that it would be show system disk space files, or let's say only show system info. You do show version here. That would be a very different command in this scenario. Okay, you may not find a equivalent one, but you can check for show running. You normally do show, uh, let's say, if you want to see a license or something on, let's say, ASA firewall, so you normally do this way, show version, and it will give you the clear picture of what license it supports. But in Palo Alto, it would be request license info. All right. So there are commands which can give you a basic inputs from the Palo Alto perspective, but they will differ. Okay. You have the options of the question mark, tabs, so that you can navigate and try to see the options here. So when I do show, I do a question mark, I will get a lot of indication that I have this many options. So let's say I wanted to check show admin. I want to see how many admins I have configured. So you can see that I have only one person called as admin configured as of now. So this is from CLI perspective. You can do ping from here. The command, by the way, would be different. So how do you ping from a Cisco point of view? You just say ping and might be you put down it as this way, correct? But in Palo Alto, it's bit different. It would be ping sourced, give any IP address of your source interface. Let's say your source interface is 1.1. And what is your host? That is your destination. So the command of Cisco gets equivalent converted into this way, which is applicable on Palo Alto, right? So that is how it is designed in Palo Alto. How do you configure something in Cisco? You normally go to configure terminal, right? And then you get into interface. You get into the interface. You say no shutdown. You put the IP addressing. But what about in the case of Palo Alto? Palo Alto, it is a single command. You have to start with a set command. Set network interface Ethernet, whatever your Ethernet ID is. Let's say your Ethernet ID is 1/1. Okay. Do you want to make it layer 2, layer 3, tab, or inline, whatever interface you want? Let's say you want it layer 3, and then you can set the interface IP of this, something in this way, right? So here we had four commands. Here we have single command. We do start with set and set that particular interface here. Okay, so it's different. It's not going to remain same. If it would have been same, then anyone would have learned the things very easily. Okay, I want to show you one more thing that you will see only in Palo Alto from the configuration. I'm not going very in depth as of now, though there are a lot of things that Palo Alto has it. So Palo Alto has something called app ID, user ID, okay, device ID. So these are some unique concepts which I'm actually not getting into. I just want to show you a basic difference between Cisco and Palo Alto. In case of a Cisco, you have a single routing table. Agree? You will have a single routing table. But in case if you have a VRF concept, if you bring up your VRF concept, then you can have multiple routing tables. Agree? Now, in the case of Palo Alto, there is a very similar behavior. In Palo Alto, we call the routing table as virtual route. Okay, virtual route or virtual router. Now, within the virtual router, if you want to keep all the interfaces and its advertising network, then it's a single routing table. But you can also change them. You can say that I would maintain a VR out separately, VR inside separately, VR DMZ separately. So basically, you can have its own routes here. Let's say these routes are for a client Coca-Cola. You can have your routes particularly to, let's say, this. Similar way, you can also have routes specifically to another company that you have. Okay, so let's say Britannia. This is something like the VRF concept of Cisco, and which by default is enabled in Palo Alto. This is also a change that you will see from the configuration behavior. What else do you uh, what else? Do you know anything else apart from this virtual router? And most of the things can be configured on Palo Alto. I can go and do a routing. I can do a static route. I can have the OSPF, BGP. I can have redistributions. I can have. So routings are all supported. Not a problem at all. There's something called as you know ISP path selection. In case you want, you specifically wanted that this particular client should go via ISP2. Okay, should go via ISP2. So there is a concept called path monitoring. You can force to go via this path, but there is also something called as there's something also called as policy based routing, where you can override the behavior of this. When do you want to override? Now let's say I configured today for a week, it is good. But then I see for next 3 4 days I have a intermediate flap, intermediate issue, and I don't want to remove this because I am sure that it's a temporary technical glitch. After 3 4 days, might be it would be back to normal. But 3 4 days I can have my path based policy. So I can say that for at least for this 3 4 days, this particular host can take up the route via ISP 01. Now, what it does, it basically will override the properties of the ISP path selection. So it's a temporary reason, right? I mean, why should you delete something and then you have to revert back if in case it's a temporary selection? So you don't have to delete it. You can add a superior policy which will override this behavior and it will go by ISP1. Now, once this ISP2 confirms if its activity is done and it's stable back, now you can remove this. You can remove or you can just close this or suppress this particular policy, and it is back to whatever it was being asked to. Okay, so this path based policies are very easy to configure over on the Palo Alto. So I'll take you to the Palo Alto dashboard. So let me show you. I once again will show you how did I get the management interface IP. So when I put this command, I get the management interface IP, which is 24.67. So I went to that over on a graphical base. This is the dashboard. I'll go to the dashboard section. On the first page, I will see all the widgets. It will show me the generic information, the number of users logged in, if there is any config logs, if there is any application related any issues. So basically, this is a kind of um, indicator to show me if my infra is good or it is at any critical risk. If it turns to red, that means there are some virus detected, there are some malware detected, and it's not a good signal. So always your ACC should be towards green or towards zero. That means you're safe. If your Palo Alto starts sensing more and more malware and more um, viruses, then this keeps increasing. It will keep going on, and it will try to hit on this the start of the red ring, which means that it's not good. So again, it's a widget to just show you, in a very prompt way that you are at risk or you are at a safer side. This is the system log. These are all widgets which you can modify as per your wish. So you can bring some more widgets. You can delete the widgets. So let's say you delete this and then you wanted to add something else, something like this. It will just add. You can drag, drop. You can do anything. This is your dashboard. Okay. And on the top end side, near by the navigation bar, you will see important tabs like dashboard, ACC, monitor, policy, object, network, and device. So most of your things would be over on this. And where is your logout button? What is this commit? Commit is like when you make some changes, they don't get instantly replicated on the actual appliance. Administrator or a senior person has to come do it manually. Okay, this is because to safeguard any actions or any push that you might have done, mistakenly or something. You don't want to do that. First, what happens is if in case you make any changes to the device, it will go to the commit candidate file. Administrators will come here. They have an option to preview the change. They'll click on OK, and they will get to know what was being added or what is being deleted. Now, if they check this and they come to know, okay, it is safe, it is just a host name that is being updated. Now they are good. They will go and commit it. They'll just click on commit button. It will take some time, and that change is applied. So unlike the Cisco's write mem, which is quite fast enough, you just say write mem, your startup config will save in the NVRAM. Whereas in Palo Alto and the Cisco FTD, FortiGate, this next gen firewall, they will be little slower. The reason is you're making the change on the graphical, which internally has to go to the actual appliance. Correct. That is why. Whereas in the Cisco, you do it on directly on the console. So when you're on the console, you do write mem, it's very fast. But at the case of Palo Alto, you don't do it directly. You're doing it on the GUI. So the backend process will happen, the backend API will happen, and then finally it will get saved in the appliance, which is as good as saving in a NVRAM. So in case if now your appliance got restarted, rebooted, or anything, the config should be in a appliance. Need not to worry. But if you would not have committed, if your configs were in here in the graphical interface, but if you had not committed, there is chances at the time of reboot you might lose your config, right? So it's always better that you save them, and I just showed you how do you commit it. So when you click on commit, the commit is successful. You get this message, and now you see it's grayed out because there is nothing more that you can save, or there is nothing to save now. So that's also a difference maker here. Cisco is direct write mem, whereas here you go to the graphical interface, you will click on the commit button. Okay, you will preview the change and then it's done. Now it is done. So where is the logout button? Logout button is somewhere hidden here. If you see the footer, you have the name of the person who has logged in right now, and just next to it you have a small button called logout. Usually logout buttons are on the top right, so always we have a tendency to see at this location, but in Palo Alto they have kept it in a corner somewhere at this point. So this is the first page. Now when you go to the next tab, you will see all the application related scoring factor, which is nothing but this graph. I mean to say this graph. So you get all the application listed here. That this is a Java program, this is a Coral program, this is a might be some PDF format, and the risk associated with that. So all your threat activity, if there is any blocked activity, tunnel activity, all the things would be visible in the ACC. And this will result in a scoring factor. So the scoring factor is 0 to 5. So make sure you don't have something at 4, 5, 4.5, which is really, really not good. Try to have it anything in 0 to 1 or 0 to 2, but not more than that. If you have more than that, then try to see what files are being considered as a threats, or what type of unknown files you are receiving. There is chances you are receiving some unknown files, and that is why the risk factors are moving towards a red area or red corner. Monitor is the section where you will capture all the traffic. So any session log, any traffic, any threat related packets, any URL filtering reports, everything you get it from the monitor section. So if you go to logs, you will see the options here. In case you want to export the report, there is an option called PDF. You will click on PDF and then you can export it either in CSV or PDF, and you will have all the reports with you. Okay. So for all the features of Palo Alto, we can find the logs under the monitor section. Policies are for the security policy. And probably if you are from a Cisco ASA background, you might have heard about only one type of policy. That is a regular security policy. You put the source, destination, port number, and mention whether it is active, allow or deny, right? But when you talk about next generation firewalls, policies doesn't only mean security policy. So these are the different types of policy. So the first one is the regular policy. I'll click on add. I can add my source. I can add destination, the different type of applications that I want to classify. I can put the service type here. Okay. And then I can say that if it is allow, deny, or to drop, or to send a reset packet saying that it's been getting dropped by Palo Alto. So you can also send the answer. Drop is a silent drop. Palo Alto is not going to send back any reset flag. But if you see reset client, reset server, reset, so basically Palo Alto will also send back a reset message just to notify the client that there is a reset happening, so that client don't get panic when you do a troubleshooting. If you see a reset packet, that means there is something on the Palo Alto side which might be blocking it. So it's a way to notify that yes, we are not accepting this traffic. So you can also have a log captures and push it to a third party profile. So there is an option here where you can click on profile and set the syslog IPs and start collecting all the traffic in a syslog format and store it in a third party tools. Okay. So this is a regular security policy which we normally do in a ASA firewall, or if you are using a router or switch and adding a access list or ACL, standard ACL. So basically, this would be a extended ACLs, not a regular standard ACL. Palo Alto don't support a regular standard; it will only support extended ACLs. So apart from this, you will see there is a NAT rules, NAT policies. You can add the NAT policy from the NAT section. So you will define what is the original packet and what is the translation packet. So there are different types here: dynamic IP and port, dynamic IP, static IP. So if you remember from the Cisco concept, you had a source NAT and destination NAT. Usually we call it as a source NAT, destination NAT, and there is something called as a PAT, which we refer as a NAT overload, right? But in the case of Palo Alto, the terminologies are different, but they mean the same. So if you see static, that is basically a source NAT, and for a destination, you have a dynamic IP, and for PAT, you have dynamic IP and port. So it's just a terminology, but ultimately it will be the source and destination. Depends upon what is the direction of your traffic. So if it is a inside to outside, inside to outside, you can prefer to go with the dynamic option, or you can also consider a path request. This is when traffic is your users are using the internet for browsing purpose. So you can set some public IP in a dynamic fashion, or you can have a port address translation, and you can do this. But if the traffic direction was from the outside to inside, right? So in this scenario, it will be a static scenario because the client will not be aware of the customers will not be aware of your private IP. So they will come with a public IP. So they will say 2.10.1.1.1. But when it reaches your Palo Alto, it should know how to untranslate to an private IP, something like this. So for this purpose, it has to be static in nature, so that when a public IP is hitting on the Palo, it will untranslate to 10.1.1 and should be able to go to the internal server. So that is, it's the same, it's almost the same, but only the naming terminology. Okay. So for source address translations, you have this many options, and for destination address translation, you have this many options. So this is a NAT rules. Similar way, you have a QoS, quality over service. So once again, you can select the source, destination, what type of application you want to give a priority, and some points or some factors. What is the class that you want to assign? Do you want to make this QoS policy a time based, like let's say between 10 a.m. to 12 a.m. or 10 a.m. to let's say 2 p.m. Do you want this to be considered? Then you can set that under this schedule. Yeah, this is what I was telling at the case of you know ISP scenario. If in case you have something, but if you wanted to override this behavior using a path-based policy, then this is what you can do. You can go add and do the needful. This is SSL decryption. You can add SSL decryption services here. In case some packet needs to be SSL decrypted, then this is where you need to write that policy. So there are different types of SSL decryption. One is called forward proxy, and inbound inspection. So accordingly, we should go and take that. This is tunnel inspection. Okay, when you add the VPNs, when you have tunnel 0, you can also inspect the traffic on that tunnel. This is application override. As the name says, you can override the features. Say, for example, if it was a PDF, or let's say if it was a traffic like TCP or UDP, let's say it's over on port 22. What type of application? Let's say, uh, let me see. Let's say Adobe Meeting. Okay, I want to give it more preference when compared to an application, or if I get something for this, I want it to be, giving a higher priority so that it don't get blocked or it don't get lost. This traffic don't get lost. Authentication is from the external third party authentication services that you use, like Google Duo, or if you have any other services which you want to set, so you can add it over here. Okay, so you can get rid of the default ones and try to have a authentication service. So this is for DOS protection. Okay, from the IPS perspective, and this is from the SD-WAN perspective. So you know that SD-WAN is a technology which also Palo Alto has it, but as you can see that they are not available until you have the license for it. Rest of the things we can do, but for some features we must have the license. So this is policies. Object, now this is also something which is a difference maker. You have no concept. Okay, there's no concepts of objects, but here in Palo Alto you have uh, object based on address, based on regions you can have, based on services you can have, based on applications you have, right? So there are different objects that you can create it. Whereas in the case of a Cisco regular routers or switch, you will not find such options. So now let me show you what does address mean. So let's say I created an address like, let's say, CCTV UK, and I added let's say 1.1.1 is that camera IP. Okay, and I click on OK. Now this is a group actually. Now if I open this, see, you can see that this is one single IP. Similar way, I can add another IP. Let's say CCTV UK 1 2.2.2. Click OK. Okay, so there are two hosts now. Now when you go to address group, you can actually make a group and add both of them. So if you click on add, you can select this, and also you can select this. You can say that all CCTV, all CCTV, and you will select OK. So now what happens is you have a group made for the different individual, right? Now this can be called upon in the policies. So when you go to security policy, you click on add, and let's say you had created some object, right? So if you want to pull that object here, you can get it over here. So let's say in the source zone, if you, so this is a zone, this is user, and this is device. So you have CCTV UK. So when you hover on that, you should see two different IPs. Okay, because that is what the object group we made. So in this way, what happens? You don't need multiple individual policies. You can have an object group and you have multiple IPs from that. Okay. This is from the based of geolocation. Actually, you can add regions based security policies as well. Okay, so let's say you put this and someone is asking you to block some connection based on latitude and longitude, then you can add them. Okay, you can add them, and this can be called in the security policies as well. Same goes with application. You have some specific application, or you want to uh, come up with your own application concept, or your own uh, custom application. You can create it. So let's say you found a packet to be reflecting unknown. So you can say classify it. You can say that it's not unknown, it's my own production, and it comes in as a media, and it's let's say it's a gaming, and then it's let's say client server, and I'll click on open. Now I classified an application. See, I classified it. So this will help you to classify the data. We are not talking about source and destination alone. We are talking about what data it is. Is it a gaming data? Is it a database data? Email data? If it is not getting classified, if it is showing you always unknown, that means the data is not at all classified by Palo Alto, right? And those data might get dropped. So you can classify those data by yourself. You can click on add. You can also add the signature. You can do a signature, because see, every day there can be chances, not every day, but you can see that a new type of data is found, and it's not in the database of Palo Alto, and it is high chances it will show as the unknown data. So you can classify them. You can just put them and classify as a media gaming, and this will also uh, be a known traffic and don't get denied. Okay, so this way, objects you have, application service you have. This is for the Palo Alto VPNs. Yeah, this is important feature here in Palo Alto. Security profiles based on antivirus, anti-spyware, vulnerability, URL filtering, file blocking, wildfire. So this security policy, this is a next gen IPS features, and you can also add them in the security policies. So if you go back, open this, there was some options to add them basically. Okay, you can actually call it, you can call here, and then you can say that I don't want to allow this. So it comes here in the profile. So when I go and click on the plus symbol, when I go to action, there is an option here called profile. So this profile is where I can select what antivirus I want. So if I have a license of this antivirus, select it, then basically my traffic will also be checked upon on all these features, and then only it is going to allow. See, so again, I'm just been pointing on this factor. It's not just source, destination, and port number. It will be much more. As you see that there are a lot of such options that you can have it on the next gen firewall. Okay, so this is the profiles. These are some SD-WAN. This is the external syslog server. You can have a different authentication process. And where do you come and configure interface? That would be under the network tab. When you go to the network interface tab, you will get all your physical interfaces you can configure. You want some VLAN configuration, you want some loopback, you want some tunnel, you want some SD-WAN, then it's over here. You have to configure zone because Palo Alto and most of the firewalls are zone-based firewalls. So you have to define that inside your different interfaces, are they belonging to same zone or they are belonging to a different zone. So let's assume if you have ISP connected to Palo Alto, and then this is your LAN network, right? So you have to define that this interface, which is 1/4, it's falling under zone outside. And also you should define that this interface is falling under inside zone. And remember, zone and zone communication don't happen. So you need to allow a security policy so that traffic can exchange between this and this. Otherwise, there is no traffic allowed. So it's a zone based. It's not like your ASA based at least. So in ASA, we had a concept of security levels. We know that a high security to low security is by default allowed. Same to same levels by default are not allowed, but we can allow them by adding the command allow same security zone. I'll say by default not allowed. However, when you add this same security allow inter zone or inter levels, it will allow them. Okay. And 0 to 100 is never allowed until you have a security policy. Correct. So this is in the case of ASIC. But in the case of Palo Alto, you don't have a concept of security levels. You have concept of zone to zone. Zone to zone example, let me give you. You can keep any names which make sense. You can keep trust, untrust, inside, outside, DMZ, customer one, customer two, customer three, any names you can give. But remember, they cannot talk to themselves. They can only talk if all the interfaces were belonging to only each individual of it. Say, for example, something like this. You have all the interfaces which belong to the same zone. 1/2, 1/3, 1/4. Then yes, they can talk to each other. But if this was the scenario, the trust zone has Ethernet 1/1 and untrust zone has Ethernet 1/4. Now they will not talk. Okay, this will not talk. You need to have security policy. You need to have a valid, allowed security policy, right? So there is also a bit of difference between a Cisco's ASA versus a Palo Alto. So most of other firewalls too, like FortiGate also follows a similar pattern. They are a zone to zone. You can keep any names, but remember, intermediately they will not talk to each other. You need to have a security policy. But if you keep everything in a single zone, something like this, then yes, they will talk. But we usually don't mix up WAN and LAN. We try to keep two different zones for that. And in that case, we need to allow for the security policies. So I have to come here and I have to say that this is the source which is originating from inside. It is going outside. So allow the traffic. So there would be two default ones which you cannot delete it, but these are default ones. Okay, this default ones are basically for intrazone. I told you for this you don't need it. That is because you by default have given the permission by the by the Palo Alto itself. You cannot either delete this. There's no option to delete this. These are the built-in ones. So built-in says that you can do a intrazone. Okay, you can do intrazone. So there is a intrazone allow, but interzone is denied. So that is why you should be writing the rules if this is the scenario. If this is the scenario, then you will write it, because by default they have denied it. And if this is the scenario, you don't have to worry because it is allowed. Okay, and this is not added by me. It is added. It's a pre-built security policy in Palo Alto. Okay, so we saw the interface. This is the zone. VLAN, because you can keep your Palo Alto act as a L2 device. Virtual wire is like a bump in the wire. You have your Palo Alto just kept in between of your network, existing network, but you don't want Palo Alto to start blocking the packet. Might be you will do all the needful config, and on a particular weekend you want to convert the Palo Alto from virtual wires to a routed mode. Because sometimes what happens, I have a working network. It's Monday, it's a business day. I don't want to bring any network down, right? But I can deploy my Palo Alto as a virtual wire, which is bump in the wire. Palo Alto will not do any packet filtering, it will not block any traffic. It will just allow or transmit whatever is coming to it, it will just transmit it. And whenever you want to convert this into a routed mode, then afterwards you will see the regular behavior of a firewall which will start blocking. So remember to put all the policies that you want to put it. So this can also be used to see what type of traffics are entering and leaving the Palo Alto. Okay. Virtual routers I already discussed. It's about the VRF here in Cisco. Same thing over on Palo Alto we call as a virtual router. You have a tunnel configuration, GRE configurations. These are the VPNs. Okay, these are some network profile. So in case you are creating a IPsec site to site, right? So this is where you come, you will configure this. This is the interface management interface. In case you want to do any changes with the management IP management ports. So basically by default, over on the management, HTTPS is allowed by default, and SSH should be allowed. But HTTP and Telnet is not allowed. Let's say you need that those of them, then you can also enable them. You can enable ping, right? We can say that this is a management interface. You can click on OK and then commit it. So basically what happens over on this management IP, initially only HTTPS and SSH would be allowed. But if you want SNMP, Telnet, ping, HTTP, then you can come over here, click this, and make the needful selection. So if you want all of them, you can select all of them like this. Okay, because you will see some of the enterprise, they will disable the ping on management, because a lot of people just initiate ping and try to cause a DOS or DDoS attack. So we can turn off those pings and etc. on this. Okay, under the device, you will see most of the administration things like host name change, NTP change, DNS change, API session hours change. So this is where you will see them. And if you want to make any changes, then there is this setting button, which is nothing but edit. You click here and you can make the change. You can say that this is a weekend PA batch. Okay, and click OK. It will start reflecting, and then you have to commit. Otherwise, if you don't commit, then once you turn off the Palo Alto, it will go off. Okay. You have device certificate, you have the API sessions. I was talking about API. So in case if your team is performing API automation, then they have a feature called token ID or session ID. So do you want to uh, uh, keep it intact for certain hours? Like let's say for 24 hours you don't want them to change, then you can do all those settings here. If you want it to be lifetime, you can do it. Or you think that there could be some session ID which was given to vendor, but now you don't want them, then you can also expire from here, so that that vendor who is now away, who is left your organization, will need username and password to get the new session created. Otherwise, he will not be able to use the API. These are some operations config to save, to take the backup, export, import of the backup. These are the servers where you can do the DNS and DP configuration. These are interface, management interface, and what you want to allow. Uh, is it a DHCP? Is it a static IP and other things? Okay. Telemetry, content ID, Wildfire is like sync with the Palo Alto's cloud. What do we have in Cisco FTD? So in Cisco FTD, we have concept of Talos, which is a cloud-based solution to identify the malwares and the blacklisted IPs on a daily basis or a real-time basis. Similarly, in Palo Alto, it would be a wildfire concept where it can go and verify for the signature if this is a valid signature, or if this is if there is any information for certain file signature, it can go and check over there. So this is from the Palo side. This is from the FTD Cisco side. Okay, and these are sessions. These are high availabilities. When you have two Palo Altos, how you enable the high availability config audits. These are the password profile, administrator, and roles. Basically, what happens is you might need more users, right? So you can create the users here, and you can also set them a authentication profile. Like, should they have it from AAA? Should they have it from uh, a Google Duo? Whatever. You can set the profile here. Okay. Do you want a role based in the sense this particular guy can only do the audit kind of commands and nothing much, or he can only do the security point of concept and nothing else. So you can do a role based. If you want to keep it more privileged, super user, basically he can do everything, but I don't want to give him. I want to give only a read only access. He is just a intern. He is just learning. I'll give him a device administrator read only. So he can just open the dashboard and just check, view, read, but he cannot delete or modify. Okay, so that is done at this point. These are the certificate management. You know that Palo Alto is capable of encryption and decryption. So you don't need another Windows server for doing that. You have VPN terminating over here, or if you have the data traffic which is encrypted users using a SSL certificate. So Palo Alto can decrypt them. So you can load the certificate here. There are some trusted certificate already. You can see a list of trusted certificate. But in case you want to create a self-signed and a lot, you know, right? And the case of lab, we usually get a HTTPS issues, right? Like something like this. So if you want to create a self-sign, we have plenty of option. I can go to the Win server and create a certificate and load it here. Or I can generate at this point itself. I can put all my required algorithms, hash bit, and I can create here and I can say that this Palo Alto is itself acting as a CA server and a, the encryption and decryption. Okay. This is response page. If you guys know, when you type some private IPs, you might get some response pages like maintenance pages or redirection pages or some notification that this is down for next 2 hours. So that's called response page. And some of them are by default created. Say, for example, this is a file blocking page, right? So see, it's predefined already. Some of them are predefined. If you want a login page, you need some decryption opt-out page. So you have this option. Let's see what is it look like. See, if you proceed with the session, then I'll open it in a browser. Let's say, where is this located? So if I open on a browser, see, this is how it would look like. If you proceed with the session, then in accordance with the company security policy, blah 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 blah. It's a response set. You can also create of your own. So in case you wanted to have an application block, but you don't want the predefined, you can also import your file. If it is a proper HTML CSS file, you can keep it here. And next time you can call this under the security policy. And if something hits that, and if it is about some response, then you can see it. This is the local user database. You will see all the users locally. But I would say that in a production, we don't create local users. Instead, we would be pointing it to a radius server, TCAS server, LDAP. There are a lot of other things, multi-factors, right? So if you have multi-factor, you can create it. You can create the certificate. You can refer which vendor you want to sync. Let's say if your company has a license with the ping ID or a RSA secure access, then you can also access that. So basically what happens is the users are not locally created, and that is not possible either. You can you can rely on a dual factors sometimes. So let's say if users are created and there is need of it second password to get into the devices, then you can set this multi-factors. And radius on the other side is when you don't want to create local, but you might be keeping a radius or a cache server and create all the users on that particular server, and that will be also something integrated with other network devices, with Cisco routers, switches, Palo Alto, all falling under a single radius server. So that way you don't create local individually. Okay, some scheduled exports, software upgrades over here. If there is anything, any new software launched, you can click on check now, and then it will check in a real time and will start pop out with notification that there is anything new found. Right. So these are the some license. These are some VM series. All right. So this is a walkthrough. We can quickly do some modifications now so that you will understand how things are handled here. So just allow me 2 minutes, and if you want to take a break, you can also take a break and come back. So I'll just place a 3 minutes break so that we can see a practical also. All right, guys. I believe you're back. What we'll do is I'll take you quick to the lab quality, and let's assume that I'm configuring some routes based on two ISPs. Okay. Let me explain. Let's say this is ISP1, this is ISP2. I have two users, right? I have two users. Might be I want them to take ISP1 as a primary, and in case of any flaps or any situation, if ISP1 is down, then I want it to take the secondary one, right? A dual ISP redundancy concept. So usually in Cisco, you will find that you should come up with a lot of CLIs. You might need to enable the first hop redundancy on the switch side. You might have to enable IPSLA. You might have to track the performance of the link, right? But here in the Palo Alto, with the help of graphical, it's made quite simpler. You will see that it's quite simpler. So first we will come up with a configs here. We will have our usual CLI commands. Nothing from this side. They will be just IP assignment. Nothing from this side either. Single VLAN. So this is just acting as a switch. And then we will configure the interface. We will configure the security policies. We will put the static routes. I'll say that go this with metric 10, go this with metric 50. So whichever is a lower metric, that will be selected as a preferable route. And we can also test by taking this off. We can power this off and we can see if the traffic has shifted on another ISP or not. Okay. So first let me prepare the config of these two routers, and then I'll go with Palo Alto. Okay, I can prepare the config somewhere here. So let's say ISP01 or ISP1 and ISP02. Okay, these are two simple routers. So only from the routing concept perspective, nothing much over here. Host name ISP1 interface gig 0/0. So I am configuring this interface. So that would be IP address. Okay, I can take it up. Let's say, okay, okay, I'll just change the IPs so that we make no mistake with the IP representation. So I'll keep it as 211.100, okay, and dot one on the Palo Alto side. So this is over here, and this IP is over here, so that we can refer back them. Similar way, On the ISP2, I'll take it like let's say 171, 1.1.100, and dot one on this side. So let's keep it here. So Ethernet 1/4 is dot one, and gig 0/0 is 100. So I believe you can see this IPs. This is one of them. This is second. This is the Palo Alto side. And on this, I will just set it DHCP. Okay, simple DHCP, so that I can reach my cloud. So IP address 211.1.100, 255.255.255.0. We can add the description saying that towards PA, Palo Alto. Interface gig 0/1, no shutdown. IP address DHCP because they are connected to ISP. And we need to add access list and NAT rules here. So I will say that access list, uh, extended type, permit, let's say all the IPs that is being sourced. Okay. So from where to where? Who is your LAN? So your LAN is 172.26.10 dot series. So let's say all this client which is originating from this, you want to NAT them before taking them out. So you are writing access list from a NAT perspective. Okay. So 172.26.10.0, 0.0.255 Yeni towards Yeni, and then define the NAT role. IP NAT inside source list. What is your ACL 101, on over on which interface you're expecting this on gig 0/1. Okay, so gig 0/1 and overload. So this is a pat command. So what I mean to say is those two users, when they are accessing, let's say 8.8 or Google, they should not take their private IP. They must take the IP which is public, and we are adding the overload command on the outside interface of this router. So basically, router is performing a NAT translations. And since I may not know the return traffic in case when I'm pinging back, I just put some static route as well. That 172.26.10.0 traffic has to be taken via Palo Alto. Okay, because if there is a chance that something comes back and I have to uh, be aware how to reach back this host, I just put a return back traffic which is towards the Palo. Okay, so this is my first config, and similar way I can have it for second one. The second one says that it's a gig interface. IP will change 171.1.100 towards PA, and WAN is towards DHCP. I will say which host you are bothered about, 26, which is over here. That is fine. This is the NAT rules. Again, that's fine because it's the same interface on both the end. So we kept the same. Return traffic is also a generic command itself. Oh, sorry, this will change. Okay, because now I will be pointing to 171, which is the IP we set on the Palo Alto 171. Right. So this will go. Yes, this will be ISP2. Okay. So this will go on to my ISP1 router. How do we copy another lab? You will do Control Shift Alt, copy here. This is a clipboard, and get into the conf t, by the way, and then you can right click and paste it. Okay. Meanwhile, I'll also take the second config, go to ISP2. Okay, there was some typo. What is that typo? Access list permit. Okay, I missed a command. That's IP. This should be IP because I'm allowing all the ports over here. I didn't put as a TCP or UDP. I'm keeping IP so that all 65356 ports will be activated. Okay. I'll just put back this few commands if in case it does not configure properly. The configs will go here. I'll copy paste. This is my ISP2 1.100 access list, NAT, and static route. Okay. So from the lab, the two ISP routers are good. Now time to configure the Palo Alto. So we will first start with the interface config. I already have the management configured. So which is my interface, which is pointing to ISP1. It is Ethernet 1/7. So I'll open Ethernet 1/7. I can comment it. I can say that towards ISP01. What interface type it is? As I told you, tap in the sense bump in the wire. Okay. Bump. This is like transparent. This is HA. This is virtual wire. This is layer 2, layer 3. I want a layer 3 routed interface. So I'll select this. And as I told you, we can have a different VRF or virtual routers to maintain routing table. But since this is a lab, so I will just keep it on default. Security zone by default would not be available. I'll create a zone now. I'll say that this is a untrust because it is going outside, right? So it's a untrust zone. And what is the IP? So I can set a static IP here. I can say that it's 211.1.1/24, right? Because on the other side, we have a router at 211.1.100. So this will be on dot one. Then I'll click on OK. I'll go to the second interface, which is 1/4. Where's 1/4? It's over here. This is towards ISP02. It's a layer 3. I'll go to again the default one. It's an untrust side because of WAN side. And this interface is 171.1.1/24. Click OK. And then you're left only with one interface, which is towards the LAN. Okay. 1/2. I'll open up 1/2 towards LAN. It's again a layer 3 virtual router default and no more untrust. I'll make it a trust. Okay. You can keep trust, you can keep inside, it's all your choice. I told you these are decided by you. But remember, zone by zone not allowed. So you have to do the needful things by yourself. So what is IP? It's a LAN site. So some private IP 172.26.10.1/24. Okay. So we have the interface with us. We can also have a zone allowed because there are two zones and they will not be allowed by default to talk. So I can put the policy here. Okay. So I can say that I want to allow the policy. So how do I allow a policy between them? So I can go into policy, security policy, add. where is traffic initiating? This is basically the name. You can say uh, in to out. You can just give a name here. You can define the zone. You can say trust. You can say untrust. Anything specific you can select. Otherwise, just keep it blank. This also blank. And then most importantly, this is allowed. And you want to monitor the session. So you can click on logs and click OK. So this way you are allowing trust to untrust. And since these are stateful, so any traffic which gets initiated will get under the connection table. So you do not need a bidirectional one. Okay. But in case if it is a fresh traffic coming from untrust to trust, then you should have another rules for it. But right now, I'm considering I will only initiate from inside to outside for this lab purpose, right? So I just kept one. Now we will go and create some static routes. So before that, maybe I'll commit once. Okay. So I will see what's the preview, because before I make the commit, I have to see what have I done. So on 1/7, I have done some IP configurations. On 1/4, I have some IP configurations, right? And on 1/2 as well, it's a LAN side and I have some changes. This was something done. That's okay. Then this is something which I done. Virtual router, I changed this, fine. I was playing around with some things here with the application, fine. We created zones, that's fine. And all those things that we were actually working, right? So there is chances sometimes when you're committing it all together, there could be something which was not proper and it might block you. It will say that uh, the commit didn't work because some other things were not properly done, because we were testing out something and we randomly selected some options there. So let's wait for the commit output. We'll see if the commit is successful or it's pointing to some error. Okay, see, this is what happens. It says that one of the things which we were just testing out is because of that this commit failed. But if you recheck the commit, okay, you can see that the configs remains untouched. That means uh, the things have not done it right. So what we can do is we can just see what did we do that time. So we can see these are all. So delete the individual object, you need to delete the group first, and then you can delete those individual things. Okay, so you can see that there is some more things under, I think, device. Let's say if I make a single word and any other changes that we did, administrator, response page. Okay, there is something else which is not letting us to do. But anyway, I'll just show you the config. Might be in the class we can discuss. So after you have the security policy and interface config, the next that we need to do is the static route. So go to virtual router. Within this, you will find all the routing protocols. So click this, and you will see a static route here. Now you need to say your Palo Alto towards ISP1 to be the primary route and ISP2 to be the backup route, right? So that is what will be defined under this. So I'll click on add. I'll say that towards primary ISP 0101. What is the destination for this? I mean, this is basically internet, right? Your LAN users are going out. You can define towards the internet as a destination for this. So which should be 0.0.0.0 all IP internet over on which interface of yours. You can define that you need to check the topology. So Palo Alto towards ISP is Ethernet 1/7. Let's pick 1/7. What is the next gateway? Next gateway is this router, your own router, which is dot 100. So you will say that's 211.1.1.100. Okay, that's the next hop. This is important. Metric low means preferable. Metric high means a backup route. If you keep metric 10, this one towards primary, then secondary you can keep it 20, 30, 40, 50, whatever it is. So metric is like cost. So cost should be less, and cost is less. That means that's a preferable route. That is a preferable ISP. So I'm keeping it 10. Now, most importantly, since this is a primary link and I am expecting my traffic moving to this, right? So the primary link should be monitored. It should be monitored. So that option I will enable over here, path monitoring. Okay. Path monitoring as well, you have a condition. On what basis you want to put a condition? Any one condition fail, this should get activated. Or if you want all the condition to be matched, you can add many conditions. Two, three, four, five different conditions you can add. If all the condition match, then only do the flap from ISP 1 to 2. Otherwise, keep one itself. But we can try with lab. This is a lab, so I can say any. Any in the sense it's an odd table. Out of four, even if one is happening, then flap it from 1 to 2. So I will say any, and there is a preempts. You know the concept of preempts in HSRP, right? When primary goes down, it switch to secondary, and then it will keep monitoring. If the primary comes up, then it can re-switch back to primary, right? So that's a preempt, and you can set it 4 minutes, 6 minutes, whatever you want to do it. It's a in terms of minutes. Now, what is the condition? That's important. How are you tracking the path? How do you come to know that the primary link is fluctuating or it's bad in shape? So you can add the condition. You can tell over here that this is a condition. It's just a condition one. So basically, you can mention it this way: condition one, and it's an enable state. What is the source IP of this interface? It was dot one, right? We will say 211.1.1. And what do you want to do with this? I want to ping internet, and that would be a conclusion. whether I have a reachability over on this surface or I should consider switching to ISP2, right? So ping from this interface to ping 8.8, that's a condition one. And what interval and what ping count? You want not to be very aggressive, then keep 10 ping. If 10 ping fails, then take a uh, take a decision, or you can make it 5, whatever you want. Okay, and click OK. Now this is a condition. Similar way, you can set many more conditions. You have your own DNS server, you have your own DHCP server. You can set many more conditions, and basis on that, we have these two options. If all fail, then do the switch. If any fail, then do the switch. That depends on this, right? So I added a static route with a better metric, better cost, and I put my condition. So this is one config which I need to do towards ISP1. Similar way, I will also define my path 2. I'll say my ISP2, which is again 0.0.0, because if it switches to uh, ISP2, then also it's an internet services, right? And which interface? It's Ethernet 1 slash 4. Who is the next hop? Next hop is this router, which is 171 series, 171 1.100. Now metric will be more because he's a secondary guy, right? So I cannot keep 10. I will keep 50. 50 cost. So that means, it will be the second backup link. And no need of path monitoring for secondary. It is done only for the primary link, not for secondary. Because I need always my primary link to be up. Only at the time of any flaps, I want this to come up. So this will be done. Okay. Now two routes, one to primary, one to secondary. Primary, we have enabled path monitoring and preempts, and it's a better metric. Better metric in the sense a lower number, basically no lower cost, and that's all. You're almost done with a dual dual path ISP redundancy. Okay. So I would have shown you, but there is something which we did during the walkthrough, because of which one of the item is not allowing us to save. So once we would have saved this, how do we come to know which route is being taken up or what is happening? That's actually checked here under the more runtime stats. When you click, when you see the forwarding table, so you will see the next hop here. You can also check the monitoring, and you will get to know if your primary link is up, down. If you see it down, that means currently the forwarding table would be pointing to ISP2. If you see this to be green, that means forwarding table would be pointing to ISP1. Okay, the primary link. That is what you see. I'm just trying once again to commit, but it feels like there was something which we just had enabled, and we should not have done that, because of that a half completed rule. I'm actually missing out my other things. Right? Anyway, I'll discuss this in the class, and I'll show you the condition. Okay, so let me take this diagram. Let's say, so I just did one portion of this. So what we did today is I set my primary path. This is my secondary path. Okay. So I am pointing both to take this path. primary. But if in case of any flaps, I am okay to take path 2. That is what I did. But I'll show you during the class that we can also bring something called PBR, policy based, which is just a click ahead. Do we have that error yet? Anyway, this is because we did some things over there. So, so how do we do PBR? So you go to policy. It's called PBF, policy based forwarding, and you can set an overriding rules here. You can say that I am aware this and this should take primary, but I also have a requirement that I should push this guy over on ISP2, which is like against what you had just now configured. So for that, you need PPF, policy based forwarding. This has a capability to override your default static route. So whatever static route you did, you can override that in case you have that requirement in the in your enterprise where they say that this guy don't need to go via ISP 1. Might be he's a log server. He is consuming a lot of data, and instead of that, he can go over on a backup link, right? So you can write a PBF policy. So you will come here, you will just say that host 172.26.1.100, and you will click on the source. Let's say he is from the trust level, trust zone, right? And what is his IP address? So that's a deciding factor. You can say that he's this guy, 26.1.100. And what destination, let's say for everything, he would be taking the ISP2 for everything. He is a syslog server. And then finally the forwarding. So this is important to know. You will select the right interface. You will say that this guy should take this path, which is Ethernet 1/4. So you will set 1/4. Who is the next hop? The next hop is this 1.100, right? So you can set that. You can say that it's IP address and it will be 171.1.100. Do you want to monitor that? Yes, because in case if it fails or there is anything that you can do needful in the case of ISP2 down, then you can do that. Okay, so you can say uh, when do you want to also put a condition for this PBF? If this next hop monitor is unreachable, select that. And who is your next hop? It's that router, right? So see, what I'm trying to do is I'm adding a PBF, but I'm also making sure that what if this is going down? I still should have my primary path, right? So that condition I've kept here. I said that let him be taking a PBF rule. He can go via ISP2. But if ISP2 itself is down at certain time, then I can't rely only on 2, right? Let me switch back to 1 itself. So I can enable that basis on this. That's all. And then we click OK. We commit. We have a better way now. So all my other hosts will take primary 1, and this syslog server will take ISP2. But for any reason, if ISP1 fails, then all of them will switch to ISP2. But if ISP2 switch goes down for any reason, then this syslog server will take primary 1. Okay, it's like a path manipulation that you can do using Palo Alto. The same thing on Cisco would have been a different approach: IPSLA, HSRP, BGP routes, and a lot of other things that you can do it. But over on the Palo Alto, this is a way. And if in case you do have Palo Alto, then this is something which you would be regularly performing. Okay, the path manipulation, which host, which network, which host, what happens if this goes down. A very important topic and also interesting topic. And all these logs we should get under the session browser. Okay, we should be able to see all the traffic logs here under the monitor session browser, and the things should reflect it. Anyway, we'll do it in the class in a proper way. So we'll start. By the way, I'll show you the syllabus copy of it. Yes, so this is Palo Alto. We will start with the beginner level first. We will have the concepts clear, packet flow clear, the different types of interface. Then we will go with the configurations. So this comes over here, and the policies. These are some labs, more labs, and some more labs. Okay, so these are something over here in Palo Alto. As you know, I would be first starting with ASA module from the next weekend, next Saturday. And I already told you we have two modules, CCIE Security and Firewall Mastery. So ASA is a common topic among this. So I would be taking a combined batch for Firewall Mastery and CCIE Sec for next 1.5 month, and then the participant of Firewall Mastery will be on a different timeline, and CCI SAC would be on a different timeline. It will be next to next classes. So one would be 1.5, 2 hours, and the next one would be 1.5, 2 hours classes. Sorry, I just opened up the same thing. Yeah, so this is for CCI Security, which I've already taken the demo in the last class. So these are the modules we are covering: SCORE, SVPN, ICE, Cisco ASA Firepower, and CCI Bootcamp. And within Firewall Mastery, these are the modules: ASA FTD, Palo Alto, F5, Checkpoint, and FortiGate. Okay, I'll drop you this both links. So you can reach out to my backend for the next onboarding process. And if you have any question, I'll unmute you guys so that you can let me know. So do you have a unmute option now?
Hello, Sagar.
Yeah.
This is Waris. So the next week firewall batch, is it going to be the same time as we had the demos, or is it going to be at
Yes,
7:30?
yes, it will be same. It will be 9 p.m.
Okay.
You will receive the Zoom meeting ID very soon over in the group. Okay. All right. So if there's no question, we will wrap up. I believe the 2 days were interactive, and you have gained a good grip on what I wanted to cover. So let's catch up in the class, and then we'll start with the, from a good pace and a good labbing session. All right. Have a great day,
Sounds
and
good.
see you.
Thank you.